Alrighty, hello and welcome to Little Pat's Race. Hey, this is a watch me video, so all you have to do is sit back and watch how I solve this problem. But pay close attention because the next one we'll do together. Alright, here is your scenario. You are teaching little kids how to ride mini motorcycles. Your best rider is Little Pat. There he is right there. And he is only 6 years old. Little Pat has entered a race. He has ridden his mini motorcycle for 2/3 of a mile. Let's just write that down. 2/3 of a mile. He only has to stay in front of the pack for another 3/4. Right there. 3/4 of a mile. And then he's going to win. What will be the total length of Little Pat's race? So what you need to do here is add these two fractions to figure out the total length of the race. And the problem is this is a denominator of 1/3 and this has a denominator of 1/4. So the very first thing you got to do is find their common denominator. So I'm going to start off by drawing the fraction boxes just like we've done in all the other videos here, and then we'll find our common denominator. Let's get started. Alrighty, so the first thing I need to do is give myself some working space here, and then I'm going to create my first fraction box, and I'll put that right there, and then I'm going to create a second fraction box, and I'll put that one right there, and they're side by side. So now I'm going to create 2/3 of a mile, and that will represent, this fraction box will represent a full mile, and I'll create 2/3 of it. And that means that I need to break it into 3 parts, and I'll do that by drawing 2 lines. So I'll draw one line here and a second line right there. And now for this one, I'm going to make it into 4 parts. So I'll draw 3 lines. So let me do that right now. And I got 1 line, 2 lines, and 3 lines. And now this has 1, 2, 3 parts. This has 1, 2, 3, 4 parts. Now, I get 2/3 of this mile that my friend Pat has ridden, right, Little Pat, and so I'll fill that in there. And then over here, I have 3 out of the 4 parts that Pat has ridden here. So I've got these 3 right here. Now, as you notice, these parts, this has only 2 parts. This has, actually, back that up. This has 2 out of 3 parts. This has 3 out of 4 parts. So they're not common denominators, and you can see that right there. So the very first thing I got to do is figure out what my least common multiple is, my LCM. And that stands for least common multiple. So I'm going to take the 3 and the 4, and then I'm going to just count by 3s and count by 4s until I find a multiple that matches, right? So I'll start by 3s. 3, 6, 9, 12. Now I'll count by 4s. 4, 8, 12. And bingo, right there I have their common multiples, right? Because they both end up on 12. That means I'm going to cut this fraction box into 1, 2, 3, 4 parts. So I'm going to go up and down now. And I'll make 4 parts. Now 4 parts means I'm going to draw 3 lines. I'm going to enlarge it so I have a little more room. So I'm going to go 1, 2, and 3 lines. Now watch what happens here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've now made this fraction into a fraction that has 12 parts. And I'll do the same thing with this one. So let's come back here to my LCM, my least common multiples, and count the 4s. I got 1, 2, 3. So I'm going to cut this box here into 1, 2, 3 parts. And let's do that right now. So I'll draw, to cut into 3 parts, I'm going to draw 2 lines. So I'll go 1 and 2. And now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, and 12 parts. So these have common parts, right? Common denominators. So now all I have to do is count up all the blue lines to count up the parts. Let's do that right now. I'm going to make a little bigger here, and I'm going to just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17 parts. Now, that is actually 17 out of 12, right? 17 twelfths. Now, let's go ahead and, so let me just say, so that's how many miles he's gone, right? And it's top heavy, which means it's more than 1 mile. We'll talk more about that in a minute. But he's gone the full race, if you added the whole race up, it would be 17 twelfths of a mile. And it's actually more than 1 mile. All right, let's go to the algorithm, and then I'm going to show you some more cool stuff with that, all right? So for the algorithm, I'm simply going to write going up and down now. So watch, I'll write 2/3, right? And then I'm going to add 3/4 to it, right? And now, my rule for adding and subtracting denominators is that I have to have common denominators. And I got a 3 and a 4, so that's no good, my friend, right? So I'm going to multiply by 1, right? And the reason I want to multiply by 1 is I really want the same number, but I want to change what it looks like, right? So I'm going to multiply by what I call the giant 1, and this 1 is going to be broken into a fraction. Now, down here, I'm going to multiply by 1, 2, 3, 4, because 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, and 4 times 3 is 12. And I want to get 12s here, right? So I'm going to multiply by 4 over 4. And I'll just plug that in, 4 over 4. And first of all, no one said it, but my goodness, those are pretty ugly ones. But they are ones, right? So it's a giant 1, which means this number will be the same size. And if you notice, I didn't get any bigger or smaller with my blue parts, but I just changed the denominator, right? So let's go ahead and do that. 2 times 2, I'm sorry, that's a 4. 2 times 4 is going to give me 8. So I'm going to draw my equal sign and 8. And then right here, 3 times 4 is going to give me 12. So I'll write my 12 down here. Now notice this. This says 8 twelfths. I've got 1, 2, 3, 4, 5, 6, 7, 8 right here, right? 8 twelfths. So this is how it's been broken up. Now, let's go ahead and do the same thing with this fraction. Now with the fourths, I got 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, right? So I'm going to multiply 3/4 by the giant 1, a pretty 1 there, right? Of 1, 2, 3 over 3. So let's go ahead and do that right now. I got 3 and a 3, and that makes a giant 1. And 3 times 3 is going to give me 9. So I'm going to just write that in, 9. And then right here, 4 times 3 is going to give me 12. So I'll write my 12 right there. And now let's notice this again. 9 twelfths. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you notice, this fraction here represents how I've changed this fraction box right there. So now all I have to do is add these two bad boys up, right? And I got 8 plus 9 is going to give me 17. And then the rule with adding or subtracting fractions is you only drop the denominator because that just tells us how many parts we've cut this fraction box into. So 17 twelfths. And as you see, this right here with my algorithm agrees with my mathematical model right there, my friends. And guess what? That's always good. All right, now I want to show you one more thing that's really cool. When I teach about fractions, I always say that fractions can be stated in 3 ways. You can say it like a fraction, 17 twelfths. You can say it like how much you get. You get 17 out of 12, and as you see, the blue is 17 out of the 12 parts that they're cut. Or you can say 17 divided by 12. And that's really important to remember all three ways of saying how a fraction is, because it'll help you with a whole bunch of other problems as you're working with fractions. All right, so now, since I want to change this, as you see, this is top-heavy or improper fraction, which means it's more than one whole, right? And if I want to change it, I'm going to divide 17 divided by 12, right? So let's see how I do that. First of all, I'm going to, right over here, I'm going to draw a little squiggly line here, and I'm going to write 17 divided by 12, right? Now, here's what I'm going to do. 12 will go into 17 one time, so I'm going to put 1 right there, and bring my 12 right here, and now I subtract, and 7, where am I? 7 minus 2 is going to give me 5, right? And then this is less than 12, right? So it's my remainder, right? But what I'm going to do is I'm going to bring this remainder up here and put it above my divisor, right? And then it'll turn into a fraction. Watch this. So I put 5/12 right there, and I get 1 and 5/12. Now let's see what's happening over here with the illustration when I do that, okay? So now what I can do, I'm going to move over here, is I can start to move some of these pieces up here, right? So I'm going to take this one away. I'm going to just erase it. Oops, let me do it in the fat marker. I'm going to take that one away. I'm going to put it right there. I'm going to take this one away, and I'm going to put it right there. And then I'm going to take this one away, and I'm going to put it right here. And now, if you notice, I've got one hole here, right? That's another beautiful one I got there. Oh my goodness, I'm making it worse. All right, I got one hole here, and then I got these 1, 2, 3, 4, 5, 5 out of 12, right? So I got 1 and 5/12, and as you see, here comes the beautiful, cool part. This here agrees with what I had for my algorithm. So this is how you solve for adding fractions that have uncommon or unalike denominators. First, you got to find the LCM, and then you just do the work like we've done with every other one. So very exciting, and I hope you enjoyed this video. Guess what? Our next one we'll do together. And until then, I hope you have a fantastic day. I'll see you then. Have a great day. Bye and sayonara.